7.2 factoring by GCF, day 2. Oh, hold on. Let me get rid of that. Yep. Stupid alerts. Anyways, last class we talked about factoring by GCF, day, and like what it means to really factor. So, some important notes. Factoring a polynomial is the reverse of distributive property. We kind of hinted at that and figured it out. And really important is that finding the factors of an expression is slightly different than factoring an expression. Okay? Finding any factor of an expression is different than factoring an expression. So, when we're asked to factor each expression, it means to reverse the distributive property and pull out the GCF. So when we're asked to completely factor this expression, x to the third plus 6x squared, the first thing, as we talked about last time, is to find the GCF. That's what it means to factor. So x to the third and 6x squared. Maybe you've moved beyond making the table, but I'm going to expand each. And then I can see the GCF, which is x squared. And then in parentheses is the pair that you multiply x squared by to get our expression. And again, it shows up here. X to the third, we're left with 1x, plus what's left from 6x squared, 2 times 3, 6. So, there we go. That's what we mean by factoring an expression. Pull out the GCF and find its pair in the parentheses. All right, let's try one more here. This is kind of something that happens. So again, we're going to find the GCF. So our GCF is 3, and the pair that goes with it, well, if you pull a factor of 3 from 6, you're left with 2x squared. And if you pull the 3 from negative 3, you're left with negative 1. Boom. There we go. And that's how we factor expressions like this. Okay. So we need to create this factoring guide because directions, all this chapter will just say to factor the expressions. So we need to know when we see factoring, like what we're supposed to do. Right? The word directions to simplify mean a ton of stuff. Same thing with factoring. So open up to a new page in your notebook. And you're going to record, and we're going to add steps as we learn how to factor that will help us when we're approaching factoring. So step 1, I always want you to think about how many terms in the polynomial. Always going to be really important. Is it 2? Is it 3? Is it more than that? The second thing I want you to think about is, do all the terms have a GCF other than 1? So if there's 3 terms, do they have a GCF other than 1? If yes, factor it out. Okay? And this is what we're going to do. When we say factor, we say find the GCF, write the GCF outside the parentheses, and write the factors left from each term inside and the operation, so it's a pair. So the example would be this that I want you to add to your notes. So if you, this one, we're going to find the GCF. 4 and 10, the GCF number is 2. X squared and x, they have a GCF of x. And its pair is 2x plus 5. And there we go. We factored that expression. Okay. But we're going to be asked to factor other types of expressions. So, to help us understand that, we're going to use distributive property because factoring undoes it, right? To think about how we can go backwards. So we're going to go distributive property, see what we get, and there's a way to go backwards. All right, this was from chapter 6, so I'm going to go with the area model. We got 8A, 2AC, 4B, and BC. So we have 8A plus 2AC plus 4B plus BC. Okay. And are there any like terms? No. All right, so my question to you is, and what we're trying to solve is, if we have these 4 terms, could you find what times what equals these 4 terms? Could you go backwards? Could you find this? Because this times this equals this. But imagine we didn't know what's up here. How could we figure it out here, right? How do you go from these 4 terms to 2 terms in each parentheses, right? How do you take the 4 terms and figure out what's on the outside? I'll say it again. If you have 8A, 2AC, 4B, and BC, how could you figure out what's on the outside? Because that's what's in parentheses. All right, so what I have here is, instead of you discovering it, because we could play around with it, it's tricky. Okay, so we're going to think about it. We're going to factor 4 terms. All right. Do they have a GCF other than 1? Do they all have, does 8, 4, 3, and 6, do they have a factor other than 1 that they all have? No. Do they all have A? No. Do they all have B? No. So that would stop you. But do you know what? Here's something interesting. The first 2 have a GCF, right? And the second 2 have a GCF, right? So what we're going to do is, focus on 2 at a time. So what we're going to do, and we're going to group, it's called, because 2 of them have GCFs, right? Things in common. So we can start there. So we have 4AB and 8B. So what is a GCF of 4AB and 8B? Well, 4 and 8 have a number part of A, 4. They both have B. And then we can write down what's left from each, which is A plus 2. Cool. And the second 2 of these also happen to have something in common. What does 3A and 6 have as GCF? Well, they have 3, right? And what's left from 3A plus 6? Once you factor out a 3, you get A plus 2. Okay, here's where I need you to take like a small leap with me. What do you notice after pulling out the GCF? What do you notice what you end up with in each parentheses? Well, you end up with A plus 2, right? And remember, this started with 2 parentheses, and so we actually found one. Since these are the same, that's in one of the parentheses, a plus 2. Mathematically, what we're saying is, here are 2 things. What do both of these things have? What factor do these both have? Well, that's a plus 2. So we'll factor out the a plus 2 from both. And then the other parentheses reveals itself. Well, what goes in the other parentheses? Well, we're left with 4b plus 3. And that is what it started with. A plus 2 times 4b plus 3. If we multiply them, we're going to get this. Let's just double check, right? I'm going to take the 2 parentheses, 4b plus 3, a plus 2. So if I do the math down here, does I have a 4ab? Yes. Do I have an 8b? Yes. Do I have a 3a? Yes. Do I have a 6? Oh, it worked! Oh. Okay. So we're going to add a new concept, which we have 1, 2 in this. We're going to add a third step. After doing first step 1, 2, we're going to look at what's left and see if it can be factored more and do it. So our newest method is, if it's 4 terms, we're going to use something called the grouping method, which we just did. Okay. But we're going to practice it 2 more times here. Right, so this is called 4 terms of grouping method. And each time we're at the factor, we're going to go through the list just to get used to it, because it's really important. Step 1, how many terms? 1, 2, 3, 4. Do they have a GCF other than 1? Do they all have y? No. The numbers other than 1? No. Okay. So since it's 4 terms, we can try the grouping method, which says group the first 2 and group the second 2 terms and pull out a GCF factor each, right? So like as if they were just these 2 terms. So 12y squared and 9y, 12 and 9 have a GCF of 3, and y squared and y have a GCF of y. Okay. We write down what's left, which is 4y plus 3. 8y and 6 have a GCF of 2, and no y's in common. So pulling a factor of 2 from here is 4y, plus pulling a factor of 6, 2 from 6 is 3. Did we do it right? Can this be factored? The answer is yes. We have the same thing in both parentheses. So that's one of our parentheses. We're reversing distributive property. And the other parentheses is what's left on the outside, or what's made up of the 2 greatest common factors. So 3y and 2. So this times this equals this. And we're just factoring. We're finding what times something else equals this, and this is the case. Number 3. I want you to try this on your own. See if you can do it. Pause yourself. See if you can figure it out. I'm going to keep going. It's 4 terms. There's no GCF other than 1. It's 4 terms, so I'm going to try grouping. RS and 5S have a GCF of S. We're left with R plus 5. What does negative R and negative 5 have in common, right? So sometimes going back to this chart will be useful. Well, it's really 1, so it's negative 1 times R. And negative 5 is really negative 1 times 5. So we can see they both have negative 1. So I'm going to pull out a GCF of negative 1. And then I'm left with r and 5. Now, do we know what one of the parentheses is? We sure do. Because we had the same thing in both parentheses, one of the parentheses we started with was r plus 5. And our GCFs are what's in the other parentheses, s minus 1. Or we say these both have a GCF of r plus 5, we pull it out, and then write down what's left. Cool. Yeah, so I want to give you some practice. Grouping method, super important. We can't leave without mastering it. Okay, so that's the end of this lesson. We'll talk more about it next class. Rewatch the video if it's confusing.